1, 2, check. 1, 2. All right. Lesson 118, more on dividing decimal numbers. We usually do not write remainders with decimal division problems. The procedure we will follow for now is to continue dividing until the remainder is 0 in order to continue the division. We may need to attach extra zeros to the decimal number that is being divided. Remember that attaching extra zeros to the back of a decimal number does not change the value of the number. Okay? It's like if you had $5 and you wrote like $5, right? You could write it like $5. If you added that, it'd still be $5. If you added that, it'd still be $5. All the zeros is just saying there's a 0 in the tens place, a 0 in the hundreds place, a 0 in the 10,000s place, a 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. That does not change that the only number in the ones place is a 5. Okay, so it's just saying that there's a 0 there, 0 there, 0 in the 10,000s place, 0 in the 100,000s place, 0, 0, 0, 0, 0. Does not change the number. So you've got to remember that. All right, example 1. Divide 6/10 by 5. The first number that goes inside the division box is a 0.6. The first thing we're going to do is move our decimal point up because we don't want to forget about that. And we're dividing by 5. 5 can go into 0, 0 times. 5 can go into 6, 1 time. Minus 5 equals 1, so we add a 0, okay? Then you just bring that 0 down, and then 5 can go into 10 2 times, all right? So how many times can the decimal point, why is 6/100 equal to 6/10? I'm sorry, 60/100 equals to 6/10. 60/100 is equal to 6/10 because you can add a 0 and it doesn't change the value, right? So that's why. Example 2. Divide 3/10 by 4. Okay, so we've got 0.3. The first thing you do is put your decimal point up there, okay? 4 can go into 0. 0 times. 4 can go into 3. 0 times, okay? So then we've got to add our 0, and then we say 4 can go into 30. 4, 8, 12, 16, 20, 24, 28. 7 times minus 28. Then you have 2 left over, add another 0, okay, doesn't change anything, bring the 0 down. 4 can go into 20, 4, 8, 12, 16, 20. 5 times, so our answer is 75 thousandths. Okay, example 3. Divide 3.3 and 4/10 by 10. So 3 and 4/10 divided by 10. As we divide, we will attach the zeros to 3.4. The first thing you do, put your decimal point up there, 0. Okay, 10 can go into 3, 0 times. Okay, 10 can go into 34. We're just going to act like it's not a decimal. 10 can go into 34 3 times minus 30. Then we get 4, add our 0, bring it down, and it can go into 44 times. Notice this. When we divide a number by 10, the digits stay the same. They have just shifted one place to the right, okay? So 340 divided by 10 is 34. You just shift your decimal point. Your decimal point is going to stay in the same lineup, but the digits are going to shift, okay? So you just shifted them, so now that 0 is right there. And the same with 10 going into 3.4. The digits just shifted, okay? To divide by 10, we shift the decimal one place to the left, okay? So when we divide by 10, we just put the decimal from over here to over here. From over here, we divided by 10. We just move the decimal place over. I did this wrong. Do it again. All right, 10 divided by 3.4. Okay, put your decimal point up there. Now you go into 34, not put a 0 there, okay? So it's going to be, can go into it 3 times minus 34, 0, 4 times, okay? The decimal point shifts one space, okay? So like it's 3.4, you just shift it over, now it's 0.34. Okay, now, example 4. Oh, you didn't know you had a fourth example, did you? Well, you do. Example 4 is mentally divide 3 5/10 by 100, okay? So, when we're going back to talking about shifting these digits and decimals and all that stuff, as we divide, when we divide a number by 10, we find that the answer has the same digits, but the digits have just shifted. We can use this pattern to find the answer to a decimal division problem when the divisor is 10, okay? Only when the divisor is 10. The shortcut is very similar to the method we use when multiplying a number by 10. In both cases, you are just shifting the digits. However, we can make the digits appear to shift places by just shifting the decimal point instead. Okay, so instead of thinking about shifting so much up here, we're just going to shift the decimal point, right? That's how I caught this error up here, was because I was like, wait, if I could do the answer in my head, and I get 0.34, and I was like 0.34. That's not right. That would be if I divided it by 100. So then I went back and fixed it, okay? Because if you ever notice a mistake in your work, always go back and fix it. Don't be okay with wrong answers when you know the right answer. It's like sin. Don't be okay with sin in your life. When you know what's right, do what's right. Dividing by 100 is like dividing by 10 twice. When we divide by 100, we shift the decimal place 2 times, okay? So by dividing by 100 is like dividing by 10 twice. When we divide by 100, we shift the decimal point 2 places to the left. We can remember which way to shift the decimal point by remembering that dividing by 10, 100, or 1,000 makes smaller numbers, okay? So, for example, if you had 3.4 and you were multiplying it by 10, you would be making it bigger, okay? 10 times bigger. So you would make this number bigger, okay? But if we're dividing by 10, you have that same problem, dividing by 10, you are going to say, I can divide 3.4. That's like if I had 3.5, so like 3.5 pens, 3 pens and a cap, okay? And I want to divide this into 10 things, 10 pieces. Every piece would be smaller, right? I wouldn't say multiply it by 10, where then I'd have 10 of these, 10 of these, and 10 of these. I'm dividing it by 10, okay? So I need to make this into 10 pieces. So I'm making it smaller. So I have to put the decimal point to the left to make it a smaller number. Instead of 3 wholes and 4 tenths, you're going to have 34 hundredths, right? All right, this was a little longer math video, but I hope that you understood it. Have a great day.